Okay, so quiz is literally just on those two sections, 2.6, 2.7. It's tomorrow. It is, hopefully, if all goes as planned, it will be on Canvas, well, on lockdown. On lockdown. Okay, multiple choice. And 10 questions. Some of these questions are going to be decide which one is the graph, so you've got to do multiple parts for it. Some of them will just say, what are the asymptotes? Some of them will just say, what's the zeros? Some of them will just say domain, so it's going to break it down into little parts, okay? So as a recap before we get into that warm-up, the very first thing you're going to do every time is what? Factor. Then the second thing you're going to do, find the domain. Set your denominator not equal to 0, and it's going to be an interval notation, unless, of course, it's multiple choice and it says otherwise. Then we check for holes. How do I know there's a hole? Good. If it completely crosses out in the denominator, right? So if I had like x plus 1 on the top, x plus 1 on the bottom. If I had x in the top, x in the bottom, and I completely cancel it out. And if I do cancel something out, then that is the x coordinate of my hole. So if I had x plus 1 times x minus 2 over x plus 1 times x plus 2, then I could cancel out the x minus x plus 1s, and the hole would be at -1. So I'd get the x coordinate by setting my parentheses equal to 0. Then everything else after that comes after I simplify. So using simplified function. Order doesn't really matter after this, except that it has to come with my simplified version, okay? You're going to plug the x of the whole in to get the y. So, for example, I would plug the x back into my updated function, which is x minus 2 over x plus 2, to get the y coordinate of your whole. I would set the denominator equal to 0 to get my vertical asymptotes. To get your horizontal asymptotes, you're comparing your n and your m. First case, if n is less than m, what is your horizontal asymptote? Top is less than. Y equals 0. N is equal to m. Leading coefficients of the numerator over the leading coefficient of the denominator. And last case is n is greater than m. And there is no horizontal asymptote. Then we check for slant. How do I know there's a slant asymptote? Good. Top is 1, n is 1 more than m. And to get slant, we divide and ignore the remainder. And I put it in y equals mx plus b format. So my vertical asymptote is x equals a number. My horizontal asymptote is y equals a number. And my slant asymptote is y equals mx plus b. I find the zeros by setting numerator equal to 0. And I find the y-intercept by plugging 0 in for x. And my zeros I would list. Good morning. All right, so zeros we list, and your y-intercepts, they go in coordinate point form. So 0, comma, a number, okay? And then, like I said, some of them are literally just going to say to graph. And you're going to want to do what you can to get to that point. It will be multiple choice, so hopefully we can rule things out. But I would say I would probably look for a hole first, and then I would go for my vertical asymptotes, that kind of thing. And then if you don't know what it looks like from there, then you plot some extra points. So if all the graphs match up with your vertical asymptotes and your horizontal asymptotes, and the zeros aren't there, then you just plot some extra points. Questions on any of that? Okay. All right, this is what one should look like. So factor the denominator, x plus 2, x minus 2, and then immediately do your domain. Negative infinity to negative 2, negative 2 to 2, and positive 2 to positive infinity. Then see if anything cancels. It doesn't, which means there's no hole. My vertical asymptotes, I set the denominator now equal to 0, so x minus 2 and x plus 2. And then horizontal asymptotes, n and m are the same, so it's the leading coefficient. Leading coefficient in the top is 4. Leading coefficient in the bottom would be 1. So y equals 4 is your horizontal asymptote. There's no slant because they are the same and not one more. If I set my numerator equal to 0, I get a 0 that is 0, but there's also a multiplicity of 2, which tells me it's going to bounce, which would be especially helpful on multiple choice. Like one of your answers might cross through, and then you immediately know to cancel it out. And then your y-intercept is 0, 0. So the only thing I knew from my initial findings was my horizontal asymptote, my vertical asymptote, and 1 0 that bounced. Sometimes the zeros are going to help you know where to go, but also in this case, they help you know where you can't go. If there's no 0 here and there's no 0 here, then my graph cannot cross through here, which means it has to go above. I checked it by plugging in a point, so I actually took and plugged in x equals 3. That's the work down here. And I found 36 over 5, or 7 1/5, and that's up here. So it confirmed my curve. Also, knowing the x-axis or the y-axis symmetry from the beginning helps me because that confirms that this curve is also in the top. And then they cannot all three point in the same direction, so it confirmed the bounce in the bottom. If there was 2 that looked very similar on my multiple choice, then I would take in, like if there was one maybe that went through the middle here, I would take in, well it couldn't because it has to bounce, but let's say it bounced the other direction, I would just plug in like 1 or negative 1 to confirm it's in the right direction. Questions on that one? Okay, wait till I go over this. Okay, so this one's 2. So this time, factor the numerator, there's not factors the denominator, but factor the numerator. Again, nothing cancels, right? Domain is negative infinity to 1, and then 1 to positive infinity. There's no hole. Your vertical asymptote is at x equals 1. There's no horizontal asymptote this time because the one on the top is bigger than the one on the bottom. There is a slant asymptote. If you divide it, you get y equals x plus 1. Make sure when you do if you're going to use, well, it does either way. If you do long or short, or synthetic division, you have to plug the 0x in place of what's missing. So I get y equals x plus 1, and then your zeros from the numerator, you get negative 3 and positive 3, and then plug in 0 to get your y-intercept at 0, 9. So my slant asymptote, I graphed. I start at positive 1. It has a slope of 1. That's the diagonal line. I draw my vertical asymptote through 1. And I had zeros at negative 3 and 3, and a y-intercept at 0, 9. I didn't even have to plug in any extra points, okay? Again, if you're unsure, you can plug in some extra points, but this time that was enough information. Questions on this one? 3. So it says, again, same set of instructions. This time, when I factor before I cancel out, I find domain. So be careful because if this is multiple choice, for sure one of your domains is going to be from negative infinity to negative 1, negative 1 to 3, 3 to positive infinity. But another choice is going to be negative 1, negative infinity to just negative 1 and not have the 3 in there, okay? Domain has to include the whole, so we do domain before we cancel out. Then, because we cancel out the x minus 3, we get a whole at 3. I take and plug into the new updated equation to get the y, which is 3 halves. My vertical asymptote comes from my new updated equation as x equals negative 1. Horizontal asymptote, y equals 1. There's no slant. Your 0 is at negative 3, and your y-intercept is 0, 3. So I plotted the horizontal asymptote, the vertical asymptote, the 2 points, which was the 0 and the y-intercept, and then the whole is a point. So I plot it. My graph has to pass through it, so I didn't need any additional information this time. But again, if I did, I would just plot a point. Questions?
Wait, why is the horizontal asymptote 1?
Because you're going to find the horizontal asymptote and the vertical, all that stuff, after you simplify. So I'm looking at x plus 3 over x plus 1, and the exponents there are the same. So it's leading coefficient. Leading coefficient at the top would be 1. Leading coefficient at the bottom would be 1.
Oh, we're supposed to use the updated one?
Updated.
So
The only thing you use the original for is the domain and the x-coordinate of the whole. And then everything after that is updated. Yep.